Hi guys, this is Mr. Urrego, and today we're finding all trigonometric functions on a 45, 45, 90-degree triangle. 45, 45, 90-degree triangle. So this is a special right triangle, and the idea is to find sine, cosine, tangent, secant, cosecant, and cotangent, all 45 degrees in this case. First things first, I'm going to label the three sides of this triangle, but now, if you notice, my hypotenuse is equal to 1. Why 1? Because remember, all these connections, I'm going to make them to the unit circle. Unit circle, radius is 1, so this is the 1, the hypotenuse that I'm showing you in this triangle. Okay, that's the same 1. So this base, the bottom and the right side, I will transfer them bottom and right side. So I'll make all those connections when I talk about the unit circle. That will be the next video. All right, so let's go with the 45, 45, 90. So in this case, these two sides are the same. Right, they're equal, therefore this is an isosceles triangle. These two sides are equal, so the length of here will be the same as the length of here. Let's call this x and let's call this x. I'm going to find the side. How long is this? That's the whole idea. For that, is a right triangle. I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. From there, we know that our hypotenuse is your c value. Okay, this is your hypotenuse, so keep that in mind always. In our case, is 1. So this is 1 to the second power. The other two sides are equal because this is isosceles triangle, same two angles, therefore those two are called legs and they're the same length. I call them x, so I have x squared plus x squared equals to 1 squared. X squared plus x squared gives you 2x squared equals 1, right? 1 squared is 1. Let's keep working. I need to leave the x by itself, so I divide by 2, divide by 2, and x squared equals to 1 over 2. I need x, I don't need x squared, therefore I have to do square root on both sides. X equals square root of 1 over 2. Let's play around with this. I can bring this radical into square root of 1 over square root of 2. The square root of 1 is the same as 1, so that's coming out of the radical, but this is not coming out of the radical. I'm not able to have a radical underneath, on the denominator, therefore I have to rationalize. Multiply by the same radical on the bottom and the top. The top, 1 square root of 2 gives you square root of 2, and square root of 2 times square root of 2 gives you square root of 4. Square root of 2 stays the same, but square root of 4 gives you 2. So when I rationalize, when I multiply times another radical, those two radicals cancel out, and that's a 4, therefore my answer is square root of 4 is 2. So this side is square root of 2 over 2, and they are the same. Now, having this, I'm going to find sine, cosine, tangent, and all the other reciprocal functions. Let's go. So I have 1, my hypotenuse, this side square root of 2 over 2. This is the same as the other side. Let's write sine of theta. In this case, my angle is going to be 45 degrees. Or if you notice, I put pi over 4, I believe. I hope I did. Sine, this angle in degrees is 45. In radians is pi over 4 radians. So sine is opposite of hypotenuse. By the way, they are the same angle, so it doesn't matter which one I take. Let's take this one, for example. Opposite is square root of 2 over 2 divided by my hypotenuse, and my hypotenuse is 1. Anything divided by 1 is the same thing, so square root of 2 over 2, and that's my sine of 45. Cosine. So instead of calling them 45 degrees, let's call that pi over 4, which is the same as 45 degrees. Adjacent or hypotenuse. If this is my angle, adjacent is next to it, but in this case it's the same measure. So square root of 2 over 2 divided by hypotenuse, which is 1. Anything divided by 1 is the same thing. So look at this thing. The sine of 45 and the cosine of 45, or pi over 4, is the same thing. Alright, because it's an isosceles triangle. So my sine will be related to the y, right? To the length of y, that will be my sine. And my cosine will be related to the x value. We'll see that in the unit circle. Let's go with tangent. tangent of 45 degrees or pi over 4, which is the same thing, is equal to opposite over adjacent. Opposite is square root 2 over 2. Adjacent, right? I didn't label this. This is my opposite according to this angle, and this is my adjacent according to this angle. Opposite is square root 2 over 2 over adjacent, which is square root 2 over 2 as well. This divided by this, because it's the same thing, my answer is 1. So tangent of 45 degrees is 1, or tangent of pi over 4 is 1. Those are the things that we're going to start remembering. Let's go. Now what we're going to do is we're going to do the reciprocal identities. So cosecant is the reciprocal of sine, right? Opposite over hypotenuse is hypotenuse over opposite. Therefore, cosecant of, let's say, 45 degrees is the reciprocal of this, which is 2 over square root of 2. I have to rationalize my denominator. Multiply times square root of 2 on the bottom and the top. The top stays as 2 square root of 2, this is for multiplying. And the bottom will give you square root of 4, which is equal to 2. Simplify. 2 from the top, from the bottom, and therefore my final answer is square root of 2. So cosecant of 45 is square root of 2. That's it. Secant of 45 degrees or pi over 4. Let's do this too. This is the reciprocal of the cosine. Same thing. Reciprocal is 2 over square root of 2. And I'll have to do the same process that I just did for the cosecant. Rationalize. Top and the bottom. The top is this times that. Remember, this 2 is on the outside of the radical and this 2 is on the inside. So the 2 is on the outside stays on the outside. The 2 that is on the inside stays on the inside. The bottom is square root of 4, which is 2. And the top will simplify with that. And my final answer is square root of 2. So as you can see, the sine and the cosine are the same. The secant and cosecant are the same, are equal. Tangent and cotangent, right, is the reciprocal of this. So my cotangent of 45 degrees or pi over 4 is the reciprocal of 1, which is 1. So that's an easy one. Okay, and that's it for those trigonometric functions. Okay, our next video is going to be on all this, but in the unit circle. So please stay tuned. Guys, if you're learning, like the video, subscribe to the channel, okay? Comment, ask me questions. Thank you for watching, and I'll see you in the next one. Take care. Bye-bye.